Welcome to this Pell 5-minute short on calculating a wetted surface area for something like a pool fire pressure relief calculation. So the sheet we're looking at is the vessel calibration sheet. We find that up here. So you go into equipment, vessel calibration. We're just going to do 1 point, so we just need a wetted surface area. If you wanted to look at multiple points and get a little graph of this, you could do the multiple points. We're going to keep it simple for this particular video, and we're actually going to use this to build up a few more and create a little bit of a workflow and a bit of a pressure relief type series in these 5-minute shorts. So we've got vessel calibration. First thing we do is the orientation of the vessel. So it could be a horizontal vessel, it could be a vertical vessel, it could be a sloping vessel. I'm not sure there's too many of those knocking around. We're going to go for a vertical vessel. We've then got this length here. It says total or cylinder. I need to think about what that means. So if I bring in a little data sheet here, so for those who've done the pressure relief course, you will recognize this. This is D303. So we've got a vessel here. There we get it on the picture. Here's our vessel. So in the total is 3.4 meters from the very bottom to the very top. That's the total length. The cylinder is the tan to tan. So in this case, it'd be 3 meters. And that's what that field means, is that the cylinder is a tan to tan. Total is the top of the vessel to the bottom of the vessel. So we're going to go for 3.4 meters. There's a total. And I happen to know the cylinder is 1.7 meters in diameter. Now, in the pressure relief course, we assume they're flat bottoms, so let's leave it like that for a minute. Now, I know we're doing a wetted surface area, and we're going to use a height in a moment, so liquid density is not that important, but it does need it for doing the calculations. So if it doesn't matter, just stick 1,000 in water. It's fine for what we're doing at the moment. And then we need a depth. And you see I've got 2.85 meters in here. Again, where that came from was we've taken the alarm level as our point for our wetted surface area. That's 2.65 meters off the bottom tan line. We've got this extra 0.2 here to involve in the dish. So 2.85 meters is where we've got that. And for those who've done the relief course, 17.5 meters is about the right sort of number. So that gives us our wetted surface area, assuming it's got a flat bottom. But of course, it hasn't got a flat bottom, it's got a dish bottom. It's got a dish top as well. So we can change these. So we can say these are dishes. And your options here, you can have a flat, you can have a cone, you can have an ellipse, we could have a dish. So dish end, the radius, at this point we might not have it on the data sheet, but typically between 80 to 100% of the vessel diameter. So I've got 100%, 1.7 meters. Your radius, the transition knuckle, again, typically 6 to 15% of your diameter. So I've gone for a 0.2. And you can see that what that's done is reduce the wetted surface area. So for those who've done the pressure relief course before, we over-egged the area by about a square meter. It's actually down to 16.3 from 17.5. But we have our wetted surface area, and then we can then use that in the next calculation, whatever we want to do. And that's simple as that. That's our wetted surface area. Thank you for listening.